Over Earth's long history, there have been dramatic changes to our climate. The ice ages have come and gone. And what's surprising is that there's a strong pattern that explains why ice ages happen when they do. This is called the Milankovitch cycle. Named after Milutin Milankovitch, his theory explains how the Earth's climate changes over hundreds of thousands of years. His theory is based on two key ideas. First, the Earth's climate is strongly affected by how much sunlight the northern latitudes receive during the summer. Second, this amount of sunlight varies based on changes in the Earth's orbit and rotation. Why are the northern latitudes so important? It's because of ice. When sunlight hits the ground, most of the energy is absorbed as heat. But if the ground is covered in ice, most of the light reflects away because ice is white. This creates a positive feedback loop. Ice forms when it's cold, but ice also reflects light, making it colder, which forms more ice. So ice is really important for climate. The northern and southern hemispheres both contain lots of ice, but there's more ice in the north because there's more land. Land has a lower heat capacity than water, which means that water doesn't change temperature as easily as land does. This is why coastal regions are generally more mild and why ice forms more easily on land. Just look at the difference between the northern and southern hemispheres. In the south, there are ice caps that grow during its winter, but not nearly as much as they do in the north. During the winter, the land above the Arctic Circle is covered in darkness, experiencing twilight 24 hours a day. It's very cold, and lots of ice forms during the winter. And this is true no matter what's going on with Earth's orbit. The key variable here is how much ice melts during the summer. This depends on how much sunlight there is during the summer. Now, you might think that this doesn't change, but it does. Milankovitch showed that over hundreds of thousands of years, the amount of summer sunlight can shift plus or minus 15%. This can bring ice ages. This can end ice ages. How can the amount of summer sunlight be changing? Well, first, the distance from the Earth to the Sun is changing. And second, the Earth's tilt is changing. The Earth's axis is currently tilted at 23.5 degrees, but this changes. Other objects influence the Earth gravitationally, nudging its tilt up and down. Every 41,000 years, it cycles up and down. When the Earth is more tilted, there's more sunlight during the summer. More summer sunlight means it melts away. With less ice on the ground, less light is reflected away, giving us a warmer climate. Earth is unusual in that its tilt doesn't change very much. Earth has a very large moon, which stabilizes its tilt. Mars has two tiny moons, and so its tilt changes much more dramatically. The next effect is the distance from the Earth to the Sun. The Earth's orbit is not a circle, it's an ellipse. Every 4th of July, we celebrate aphelion, the day that the Earth is farthest from the Sun. Then in January, the Earth moves closest to the Sun. Now the planets Jupiter and Saturn both nudge the Earth, causing its orbit to shift slightly, becoming either more oval or more circular. This happens over a period of 100,000 years. This effect is wildly exaggerated in this diagram. It actually looks more like this. You can barely even see that the distance to the Sun is changing, but this subtle change has important consequences for our climate. Earth as a whole receives 6% more sunlight during January than it does in July. The seasons change because the North Pole sometimes tilts towards the Sun and sometimes tilts away. The change in the distance to the Sun, this works against the change in the seasons. This moderates the seasons in the north since the Earth is furthest away in July. But this was not always true. The Earth's axis is moving in a circle. It's spinning like a top. This is called precession. In fact, I made an entire video about this. And what this means is that 13,000 years ago, the tilt of the Earth, when the Earth was closest to the Sun, it was summer in the north. The distance change didn't oppose the seasons, it amplified seasons, making them more extreme. Now, warmer summer means more melting. More melting means less reflection, which means the climate as a whole is warmer. The amount of summer sunlight is affected by 3 long-term cycles. 1 changes the tilt. 1 makes our orbit more circular or more oval. And 1 changes how the distance to the sun matches with the changing of the seasons. These 3 cycles powerfully impact our climate. Scientists have measured the history of our climate using ice cores. Now, Earth's climate is complicated. You can't just reduce it to a single input. But the Milankovitch cycles have played a key role in our climate for hundreds of thousands of years. For more
You are all trapped in here with me! Rebooted robot hell, you damn savages!
Not good!
I am the Ubermensch!
Come on, tough guy! Go incoming! Go!
dead. Not a big surprise.
The Saturn V rocket that lifted the Apollo 11 spacecraft out of Earth's orbit had been reduced to its final stage, the S-4B. The Command and Service Module, or CSM, separated from the S-4B, turned through 180 degrees and docked with the Lunar Module, or LEM. The now combined CSM and LEM pulled away from the S-4B rocket, proceeding on its roughly 250,000-mile journey to the Moon during the translunar coast phase. Almost 3 days later, the spacecraft entered lunar orbit. The crew spent the next 25 hours performing various systems, checks and tests while in orbit around the Moon. In preparation for landing, Neil Armstrong and Buzz Aldrin transferred to the LEM while Michael Collins remained in the CSM. The CSM undocked and separated from the LEM. Now functioning as two separate vehicles, the CSM was redesignated Columbia and the LEM Eagle. Eagle's descent orbit initiation began, followed by the powered descent initiation. After 102 hours and 45 minutes of travelling through space, Eagle became the first manned spacecraft to land on the Moon. Once safely on the lunar surface, Armstrong and Aldrin performed a checkout of all systems and prepared for their historic moonwalk. 109 hours and 42 minutes after launch, Neil Armstrong became the first human to set foot on the lunar surface and delivered his famous words, Aldrin joined Armstrong on the lunar surface shortly after, and the pair collected lunar surface samples and conducted experiments. They stayed on the Moon for just under 1 day. Eagle ascended from the lunar surface to rendezvous and dock with Columbia, which had been orbiting the Moon during the lunar landing. Columbia docked with Eagle, and Armstrong and Aldrin reunited with Collins in the CSM. The LEM ascent stage was jettisoned, and the CSM entered the trans-Earth injection phase to make the voyage back to Earth. The service section of the CSM was ejected before entering Earth's atmosphere. Finally, 195 hours, 18 minutes and 35 seconds after departing the Earth, the command module splashed down in the Pacific Ocean on the 24th of July after travelling a total distance of over 800,000 nautical miles.